This is the Hemispheres firmware for Ornament and Crime. It's an alternative firmware you can install which gives you new capabilities on your existing module. In this video, I'll explain how to install it, how it's different from the standard firmware, and some tricks you can use when making patches with it. This is the first in a series of videos, so stay tuned for more as I explain the Hemispheres mode in more detail. Okay, let's get started. The first thing we need to do is download the Teensy Loader application. This will install the firmware on the Ornament and Crime force. Follow the link I've included down below in the description, and you'll see on the website here that you can actually choose the download for Mac or Windows or Linux, and it gives instructions on how to load the image file into the loader and then click the button, which I'll show you in a moment, to download it into the Ornament and Crime. Next, we need to download the firmware file for the Hemispheres software. You can go to the link I've included down below, and what you want to look for is this .hex file. Click on that to download it, and remember where you located it, because you're going to need to load it up into the Teensy Loader, which we downloaded in the previous step. Now I'm going to show you how to install Hemispheres onto the Ornament and Crime. I've got an Ornament and Crime in my case here that's running the standard firmware. So to install the Hemisphere suite, I need to use the Teensy tool, which I showed you how to download. And we're going to need a USB micro cable like this one here. Power off the case and take the Ornament and Crime out. And if you look on the back of it, you'll see this board here, which is the CPU board. On the side here, there is a little micro USB plug. So I'm going to just plug this in here and just leave it sitting outside, because there's a small switch that you have to depress here to actually enable the firmware download process. So what I'm going to do is get my Teensy configured over here in auto mode with the firmware image loaded up as I showed earlier. Hold this button down here, turn my case on, let the button go, and now, yep, I can see on the screen it's programmed in, and now you can see on the screen here a completely different firmware, which is the Ornament and Crime running Hemispheres. You can download the standard firmware image at any point and load it back into the Ornament and Crime, so you're not limited to just running one or the other. It's easy to switch between both. I always just make sure to power down before taking the module out of the case and putting the USB cable in, just to avoid any short. It would be terrible to blow all your power lines if you were doing an install and something just touched off one of the power lines. Before we look at patching, let's do a quick walkthrough of the user interface, because there are some differences between how Hemispheres works and the standard Ornament and Crime firmware. The first thing to realize is the Hemisphere suite is broken down into two halves, and hence the name Hemispheres. You run an applet on the left and an applet on the right, and they're generally independent from each other except in a few circumstances. Press the up button to select the applet and then turn the knob corresponding to that hemisphere to choose between all of the different applets that are installed, and there are quite a few of them. You can run the same applet on both sides, or you can run two different applets. And of course, you can change as you're playing. With only one knob and one button, you need to get a little creative for controlling the applets, so they tend to have a very simple user interface. For example, sequence 5 is a 5-step sequencer. You select which step of the sequence to edit by pressing the knob, and then you adjust the value by pressing or by turning the knob corresponding to that entry. The inputs and outputs on the Ornament and Crime are also broken down in half. So for example, the left applet takes inputs on these two triggers, these two CVs, and outputs on these two outputs here, and the same for the right applet. Hemispheres also has apps, which I'm going to cover in a later video. If you long press the right button, it brings you to the main menu where you can choose between all of the different apps available. A long press on the right button again in the main menu saves the current state of the applets you have configured. One of the advantages that Hemispheres has is that it has a clock built in, so you can clock it using an internal clock signal. Long press the down button and that will take you to the clock setup. You can configure the clock in one of two ways: forwarding mode or internal mode. Turn the right knob to select between them. Internal mode turns on the internal metronome, and you can press the button to select the different parameters and edit the BPM and the clock scaling, which goes from 1 upwards. Long press the right button and you're back here, and you'll notice that there's a little metronome symbol here appearing on top of the left applet. To start the clock running, long press the left button, and now you see the metronome is ticking and a clock signal is going to the applets. If those applets are configured to accept clocks, they will then start to behave according to if they got a clock on their input triggers. If you prefer to clock your applets from an external source, just go back in here, turn that to forward, and now clock forwarding is enabled. Now that we've gone through the user interface, let's wire up a basic patch and explore some of the more common applets. The first two I'm going to start with are a 5-step sequencer called sequence 5 and an envelope generator. This applet generates an ADSR envelope, an attack, decay, sustain, release envelope. I'm going to start off by firing the sequencer. We're going to use the sequencer clocked by palms, and we are going to use the two oscillators in the clavis twin waves here. Oscillator 1 will be sequenced by this sequencer. I'm going to send that out into my filter here. So let's get wiring up. We'll start off with a clock here from output 1. Trigger 1 will clock the sequencer. So if I press play here, you see now the sequencer is running. The little dot moves along. If I only wanted a 3-step sequencer, or I wanted to remove steps, simply dialing this down to 0 effectively skips the step. You see the little dot jumps over that step. The sequencer is quantized to semitones, and so the range you get here is about 32 semitones. So we'll take the output of the sequencer, it comes out here on output 1. I'm going to put that into volt per octave 1 here on the twin waves. I'm going to take the output of the twin waves, and it's going to go into the left input here on my filter. And now we need an envelope to trigger this. So let's patch in the output of the envelope. Now I need to send a trigger in to play the envelope. So if I do this, you can see the sequencer is running, but because no envelope is being sent in to the VCA here in the oscillator, we're not hearing any sound because there is nothing to open up the VCA. Let's send a clock in to the envelope generator applet. Now remember, it's on the right-hand side. So these two inputs here are mapped onto this applet. These two inputs here are for this applet. I'll send the clock in here on trigger 1. And now if I hit play, we can hear sound. Let's play around a little bit with the envelope shape. So it's got a fairly quick attack, decay, sustain, and release. So I'm going to sharpen that up. You can hear the attack is quite sharp. Now if I elongate it, much longer attack. What if we wanted to make the sequence a little bit more interesting? Right now it's just going to play the same 5 notes over and over again, which I've quantized onto the minor key here on the twin waves. If you send a control voltage in on CV1, you can repitch the output of the sequencer. So I'm going to take the output of the mimetic digitalis on sequencer 1. I'm going to use that as a source of random control voltage to repitch what's happening out of my sequencer. Now if I jump around, you can hear that the pitch of the notes is changing. Let's program that in a little bit more automatically. So I'm going to send a random trigger into the OR trigger input there on the mimetic digitalis. Now, when a trigger arrives over here, it'll jump to a different spot on the grid. And I've set this trigger to go off every 8 beats, which means it won't line up exactly with the same note each time in this 5-step sequencer, so we'll get a bit more variation. What about introducing a second oscillator? Well, we have 2 oscillators here in the twin waves, so let's use that second oscillator and play it as well using the sequencer. I'm going to patch the output of the second oscillator into my VCA input here. So the output of this VCA goes into the right channel input over here. Now I need an envelope to open up this VCA. Where am I going to get this envelope from? Well, it turns out the envelope applet can actually generate 2 envelopes in response to 2 triggers, one on this input and one on this input. Remember, I'm running the envelope generator here. I can have this applet over here and it would be the A and B input instead of the C and D input. Both of the envelopes will be the same shape because you only have one envelope shape to find here, but they can respond to different triggers. Now, if I patch the output of that second envelope into the input of the VCA, we'll be able to hear the second oscillator. Now when I hit play, we can hear the second oscillator. The second envelope is firing on a slightly different clock, and the oscillator is playing a tone. But it's still playing the same tone over and over again, so let's just do a quick bit of repatching here. Now let's take a listen. Well, it's not going to win any awards for musical quality. But you get the general idea. That's a great example of just pulling some really useful functionality out of Ornament and Crime. I needed an envelope, and then I needed a second envelope, and I was able to solve it very quickly using this applet. I needed a quick sequencer to just generate a sequence of notes, or any CV values that you needed for anything, and I was able to generate it using the Sequence 5 applet. With a little bit of creative clocking, I'm able to get some very interesting rhythms out of it. Now let's look at some more applets, and two I've chosen here are the brancher and the burst generator. Brancher is a probabilistic gate router. So as a gate arrives here on input 1, the probability percentage here dictates whether it'll be output on the output C or D here. Now obviously if brancher was running on the left hemisphere, it will be output A or B. So at a 20% probability, that means 2 out of every 10 gates that arrive on the trigger input will get sent out to output C. The remainder go out output D. We can use this to route gates probabilistically to different places. So what I'm going to do is use this brancher to trigger the other applet, which is the burst generator. The burst generator generates bursts of triggers. When a trigger input arrives on trigger input 2, the burst generator will generate the number of bursts you've configured here in this parameter, and you use this left knob to select between them. So I've set it to 8 bursts, and the bursts are going to occur every 119 milliseconds apart. You can also send a clock into trigger input 1, which will clock the rate at which the bursts are generated, and then you set that based on a clock division here. So let's get this wired up. What we'll do is we'll send a gate out from PAMS here into trigger input 1 on the brancher. And now what will happen is this will send in triggers, and you'll see sometimes it'll jump over to output C there. That shows the output of the gate is actually being routed to output C, and so most of the time it's going to output D. If I was to change this probability here to 50%, you'd see it would flip between them far more frequently. But I'm just going to keep this down here at about 20, maybe even 15% for now. Now let's wire up the output of the brancher. So the regular output, shall we say, the most common output, will just advance this sequencer by a single step. So I've just patched the output of output D here into the N input on the mimetic digitalis, which will advance the sequencer step along by 1 position. I then patch the output of the less frequent branch, the C branch, which will occur much less frequently, into the trigger input for my burst generator. And what this will do is it will trigger this 15% of the time and generate 8 bursts of gates. And I'm going to take those 8 bursts of gates here, and I'm going to feed them into the X input on my mimetic digitalis. So we'll make little bursts, little loops like ratchet effects, which we can then use to create an interesting sound effect. Okay, now let's take a listen. I've turned off the internal VCA in the oscillator on twin waves, so you can actually really hear the bursts being generated. So I'm just going to turn up the volume. And you hear there, whenever there is a burst generated, when the output C is triggered, you'll see the burst of notes being created here. Watch here on the sequencer. It skips along very quickly through the notes. Otherwise, it's just progressing slowly whenever there is a gate coming out here. We can also put this relative probability under CV control. I'm going to patch a random voltage source here from PAMS into the CV1 input on the brancher, which will adjust the relative probability. So you see it's quite a high value right now, so it's more probable we'll get bursts. And now we've got a much lower value, so the probability has gone down. So this shows two additional applets you can use to create some very interesting variations. A random probability brancher and the burst generator, which you can use to generate burst or ratchet effects with drums. Ornament and Crime can also do some basic audio manipulation. Now you're not going to get some very high resolution output from this because you are limited by the resolution and speed of the processor and the analog to digital converter. But we can have a bit of fun, and if you like lo-fi effects, you can actually get a lot out of it. I've got two different applets loaded this time. The one on the left is called LowerRenz, and it's a LowerRenz generator, which is a very simplified version of the one you would find in the standard firmware. Essentially, it generates an X and a Y output, which look somewhat random and chaotic, but are actually linked by a mathematical formula. You adjust two parameters here, the frequency, and the higher the frequency, the more rapid the changes here. Lower frequency, slightly slower changes. And a kind of parameter called rho, which you can vary, and it changes the movements of the two outputs. You'll see the two outputs here on the X and Y output. I'm just going to take the outputs and I'm going to patch them into the parameters on this oscillator here on Twin Waves. I'm just going to open the oscillator up and we're just going to have a little bit of fun listening to the output just being modulated by these two parameters. And I'm going to patch the second parameter into the filter frequency. I might increase the Now we're having a bit of fun with it to see how it's varying quite a lot. The other thing we're going to play with is this applet called DrCrusher. And DrCrusher is a bit crusher application, or applet I should say. It's running in the right hemisphere here. Now you are limited quite significantly in the fidelity of the audio you can generate and input to Ornament and Crime, but for our purposes it's actually quite good because it gives us a lovely bit crushed kind of lo-fi vibe. Output C here, which is the left output, is going to be the bit crushed lower fidelity version of the input, and output D will be as close to the original as you can get out of Ornament and Crime. So I'll write that into the right channel. I'll pop the output of my oscillator into the CV1 input here, and you straight away see an animation on the screen. I'll turn up the volume. Now there's no CV modulation on DrCrusher, so you can change it by changing the parameter here, reducing the sample rate speed, or you can reduce the number of bits, the resolution, all the way down to 2 bits. Almost sounds like a formant generator there. I set this oscillator to be an additive mode with both even and odd harmonics, and then we're modulating the filter cutoff using this rather random looking pattern generated over here, along with some bit crushing. It almost sounds like some sort of formant generator oscillator. The Hemispheres app has an awful lot of comparison functions and logic functions. And logic functions really are useful when you want to generate unusual rhythmic patterns by comparing values against each other. Let's use the compare app to generate unusual rhythms to gate into a VCA to play the oscillator. Compare is a very simple applet. It really just takes the input and compares it to a value that you define. So here, using the left knob on the left hemisphere, I have the line here defining the comparison point. If the input is higher than that value, this output A goes high. If the input is lower than that value, the output B goes high. So basically it's an comparator. So if it's high, in other words, basically compare does a comparator function and you get two gates, either A or B. And you can use those obviously to trigger anything you want to trigger, but in this case I'm going to use them to trigger this VCA so we hear the oscillators playing on different rhythms. I'm going to use the mimetic digitalis as a source of just random values to input into the comparators. So I'm going to take the output here of sequencer 1 and I'm going to pop that into this input here on CV1. Now when I press play, you'll notice that the output changes, goes on and off depending on whether or not this little line is above or below the input. The bottom bar shows what the current setting is to compare to, and the top bar shows what the input value is. Let's take the output of the comparator. We'll patch it into the CV input of this VCA over here. I'm going to take another output, this time from sequencer 2 into the volts per octave input on my oscillator. So oscillator 1 is going to get its pitch sequenced by sequencer 2 on the mimetic digitalis, but the rhythm that's going to be played is going to be generated by whatever the compare applet creates. So we've separated out rhythm from pitch, which gets some very fun and interesting results. Let's patch the output of the oscillator into the input of the VCA, and we'll patch the output of the VCA into the left input of the filter. Now that we've got this all patched up, let's take a listen to what we get. So the VCA is set to exponential decay, and I've dialed up the CV attenuation here. So every time a gate comes out of the compare applet over here, it'll open up the VCA. Now, strictly speaking, we should be doing this with an envelope, but there'll be a little bit of roughness to the edges because we're sending a gate in. But let's take a listen and see what happens. So you can hear a very interesting rhythm. And as I change the value to compare to, that rhythm changes. That's much smaller, so more notes get played. Let's do the same thing with the second oscillator. So I'm going to patch, say, this into the CV1 input here for comparator number 2, which is going to run in the right hemisphere. We'll take the output of its gate into the input of the VCA. We'll patch the output of the oscillator into the input of the VCA, getting a little bit messy here, but you follow along. And then the output of the VCA is going to be patched into the input of the filter. So now we have oscillator 2 being gated by whatever is compared from the comparator in the right hemisphere, and we'll just patch in a different melody there into oscillator 2. I'll just tidy up these cables a little bit so we can see what's going on. So now oscillator 1, the rhythm comes from whatever is compared out of sequencer 1 in this comparator, and the pitch comes out of sequencer 2. Oscillator 2, the rhythm comes out of sequencer 3, and the pitch is coming out of sequencer 4. Okay, now that we have it patched up, let's turn on oscillator 2 and hear what it sounds like. So you hear oscillator 2, its rhythm is coming out of comparator 2 here. And I can adjust these independently. So there you heard that by just changing the compare values, we're able to change the rhythm being generated because the input value had to be greater than that threshold before a gate gets generated. With the compare applet, you can also modulate that threshold by sending a bipolar CV value into the CV2 input. So you could actually dynamically be changing where that threshold point is as your notes are being played, and you can get some pretty crazy rhythms So now I've sent in a triangle LFO from PAMS. It's a fairly slow LFO, and I've also limited the level it can go to. Now, PAMS can only generate positive voltages. This is not a bipolar modulation, so I'll only be able to increase the threshold, not decrease it. But you'll see the lower bar shift as the LFO ramps up and then ramps down. Let's have a look. You see the lower bar is shifting now as I modulate the threshold using the input here on CV2, and as a result, the rhythm of the notes is changing. I hope you found this video useful today. This is the first in a series of videos on Hemispheres which I'm making. Next, I'll be covering Darkest Timeline, which is a sequencer application in the firmware. Don't forget to leave me some comments or questions down below, and hit subscribe if you want to get notified of future videos. Thanks for watching.